Hey, we're back with Azure in the Enterprise with Josh Long. Hey, Josh, how are you?
Hey, how are you?
So you are like the spring guy. So in this video, yeah, you are the spring guy. So what are we going to talk about in this one?
Well, let's talk about Microsoft SQL Server and how to connect to it from a Spring application. Now, I love SQL Server. I love uh, as a person who has spent a lot of time in the enterprise. I really like venerable, tried and true pieces of technology like SQL Server. And I remember a lot of really positive experiences with it because when somebody else was paying for it, it was really nice as a developer to be able to run it. Right. I liked that. But of course, back then, running it was very expensive because you had to buy the whole thing and all that. Now it's just this on demand pay as you go thing in the platform. And best part, somebody else is running it, right? So that's a whole team of people that I used to remember having to talk to negotiate any kind of interaction with the database. No longer do I need that, right? Because nobody's. I mean, the platform runs it for me. Azure runs it for me. That's the really, really compelling feature here. Obviously, there's still value in having a dedicated DBA who understands how to write queries and all that, but I just didn't need so many people involved in the operations of it anymore, right? And that's really compelling. So what I want to do is I want to talk to it from my Spring application. This is not a hard thing to do. It's just a SQL database, right? So Spring applications can talk to SQL databases all day. What I want to demonstrate is how easily we can do that for an instance running on the platform here.
Sweet. And then I think at the end, I'll also tell a little story of what we've done internally with SQL that I think is kind of highlights what people can do when they go migrate and move to Azure.
Okay, I'd love to hear that. I love. Is it? Okay, yeah. Don't spoil the surprise. I want to help you. So let's just build a simple application. There's a couple of ways to provision the instance, right? One is to write a script. I'm using Bash. You can use PowerShell. Doesn't matter, right? Anything will get you there. So long as you have the Azure command line client on your system, you can then you can say I want to create a SQL Server instance, right? I'm just going to create that. Then I'm going to set up the firewall to allow my client IP, and then I'll do a SQL Server database creation. So I'm going to create that within the SQL Server instance. And this is a one-to-many relationship. I can have one server and multiple databases within. And I'm configuring my my username and password and all this. This is not my actual password. But that's the password you're going to need to talk to your SQL Server instance. So I've already done all that. You could also do this alternatively by going to SQL databases here in the Azure portal and just click on add, and it'll give you a wizard. Microsoft's famous for their amazing wizards. So create a database name and point it to a SQL Server instance and scale it up, right? And so I can use SQL Elastic Pool. That seems pretty interesting. What is that?
So that basically allows you to kind of like stretch and burst. There's a whole host of stuff that I'm not deep in on it, but essentially it's one of those things where like if you really want to take advantage of Azure's elasticity, it will kind of move tiers for you to make sure that your app is always happy.
Nice. So is that scale up as well, or is that the next thing? Is that the compute and storage support?
I'm actually not sure.
Okay.
I'm more of a Kubernetes Linux guy. So
okay,
but I used to be a SQL DBA in back in the day, so I was the one that maintained all the indexes.
Oh, so that's cool. So either way, it looks like there's some facilities here where if I should exceed my provisioned capacity, there's some mechanism I can use to scale up, right? That's what I think I'm understanding here, which is cool.
It's not a hard limit. So it's one of the nice things that we do is if you've got a runaway query or if somebody's going over your limits, like we're not going to like just hammer right on you. If you're constantly going over it, then we our advisors may tell you, hey, you should size up, but we're not gonna. It's not a hard cap.
And you can do that, so I can actually just point and click until I'm scaled up.
Yep. Yeah. So one of the nice things that we have here is our when you choose a tier, it's basically an SLA. So it's not like sometimes if you're going to go resize a VM or change classes of a VM, it's got to shut down and reboot. Like this is all online.
Wow, that's so cool. That is cool. So that's not a thing you could have easily done, at least to my mind, 20 years ago when I first started using SQL Server. The fact that I can do that is just sorcery, witchcraft. So I love that. So okay, so I've got a SQL database provisioned. I'm going to go to SQL databases. It's called the Beautiful SQL Server DB. It's online. There, I can actually interact with the database, right? So if I want to, I can go to the query editor, and I have a username. I've already provisioned this, remember? So it's Beautiful Admin, and I need to give it a password. I'm not going to show you my password because, hashtag security, but I am going to just copy and paste it, right, into my pasteboard buffer and paste it there, logging in. And so you can see I've got a view of the database. I've got my run of the database, and I've got a table there. And so what I want to do is I want to issue a select all against that table. That was nice, convenient for me. And there you go. I've got 3 records. So what I'd like to do is to build an app that brings that data down. So I'm going to go to my favorite place on the internet, after production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, then you can begin your journey there with start.spring.io. And what we're going to do is we're going to use the Microsoft SQL Server driver. We're going to use JDBC support. We could use JPA, right? Anything that supports JDBC, MyBetas, right? Anything that we will use there, Java, OOQ, anything would work just fine. But for our purposes, I think I'll constrain our choices to just the JDBC and the slightly higher level Spring Data JPA. And I'm going to bring in the latest version of Java that's stable for my purposes. In Azure Spring Cloud, for example, if you want to run your application, you can use Java 8 or 11. Java 14 is the current supported version of Java, but it's only for 6 months. So the current long-term supported version of Java is Java 11. And we're going to call our application SQL Server. All right, I'm going to hit generate. And that'll give us a zip file here, right? So I'm going to unzip this SQL Server, cd SQL Server, Maven install. Just make sure it downloads the dependencies and so on. So it's all there. Good. It failed because, of course, there's no connection string there. So let's open this up in our IDE. I'm going to use IntelliJ. That's a pretty common choice. But of course, you could use Microsoft's amazing open source Visual Studio Code. You could use Eclipse. And actually, that could be a whole other topic. We should have another video on that. But the Visual Studio Code support that there's support for building Spring apps within Visual Studio Code. That support came from the Eclipse integration that we had built, and then extracted out as a language server. So now the support that we built for Eclipse that has served people for so long, for decades, is now part of Visual Studio Code. It's now part of Emacs if you want. You can use it from GitHub's Atom. I mean, anything, right? All because of this.
Yeah, I think
amazing language
a really
server.
popular thing that I see right now is people using, running on Windows with Visual Studio Code and then using WSL2. So I mean, like anytime I'm working with Azure, even though I'm sitting on Windows, I'm actually very routinely run everything via WSL2. So I use all of my Linux commands from my past days, and then I actually open up code from the Linux prompt and from Bash, and do everything that way.
That's awesome. WSL2 is Windows subsystem for Linux.
Yep.
Okay. So I've heard good things. I should try it. I love Linux. I've got a dedicated Linux laptop as well. But I think I should try just running Windows and just going full all in. Okay. So I've got my instance here. I've got my database. I'm going to go to connection strings area. Sure, discard the data, no problem. And I've got connection strings here for ADO, for .NET, for ODBC, for plain old Windows applications. Some of these other non-Java Spring platforms, nobody knows what they are, nobody cares. Let's see. And we've got JDBC. And JDBC is for Java, right? So this is the Java Database Connectivity Abstraction. That said, JDBC is a blocking abstraction. So when you interact with the API and you're sitting there on a thread, it's going to block until the bytes have been returned from the network socket or whatever. It's going to wait on that thread, which means that nothing else in the system can use that thread. So to map that more to .NET use cases, we don't have async await on the JVM, right? If you're using languages on the JVM like Kotlin has something like that. It's called a coroutine. And if you're not using something like coroutines, but you want non-blocking I/O, then you need to use something called R2DBC, which is a different abstraction for connecting to databases, and it's a non-blocking API. And the point is you can derive very easily the R2DBC connection string from the JDBC connection string. It's a different API, and so the connection string is a little bit differently. But the point is, from this, you have everything you need to be able to write the R2DBC connection. And R2DBC works perfectly with Spring as well. And Microsoft SQL Server, there's a SQL Server, there's a reactive, non-blocking SQL Server implementation. So that works nicely for both traditional blocking and non-blocking applications. Okay, so the connection string has everything we need except for the password. So I'm going to put SQL Server PW, right? That's this here. And it, in turn, is going to reference that environment variable that I just used a second ago to capture my password. Okay. And then I need a username, so spring.datasource.username. And the username is Beautiful Admin, if memory serves. And then we need the password. So password equals SQL Server PW. All right, so there we go. That's all we need to connect our application to a JDBC-centric data source. For now, let's just comment out JPA. Okay, so we're using the lowest level. This is like table stakes for talking to a SQL database. It's called the JDBC template. The JDBC template is just a very convenient object that's been in Spring Framework for 18 years, basically, since 2002 at least. And the JDBC template is a thing you can inject. You can have it injected into the constructor of your component. So I could create a constructor manually like this, or I could just do @required args constructor if I were using Lumbuk, but I don't have Lumbuk on the class path, it looks like. So let's go ahead and add that. Lumbuk is just a compile time annotation processor. It makes it so that I can create annotations, the equivalent of attributes from C#. I can use annotations to synthesize getters, setters, toStrings, all that kind of stuff. So no args constructor, there we go. And actually, you know what? I need a required args constructor. There you go. That'll create a constructor for that final field. And then once that's done, I'm going to make this a component that listens for a lifecycle event, particularly the application ready event. Public void ready. Okay. And once that's done, I want to make a call to the database. So I'll say this.template.query, select all from customer, right? And we saw that I could run the query here, right? We saw that it was not hard to figure out a valid query. I should have copied and pasted that while I had the chance. So it's fine, it'll work either way. So there we go, I've got this. And now what I want to do is I want to take each record that comes back from that row and then map it into a Java object, which I'm going to then accumulate into a collection. So I'm going to use a row mapper, and a row mapper maps, as you can imagine, a row to an object, but I need to give it a type to map it to. So I'll create a DTO, an object here called a customer, and the customer will have an integer field for the ID, and it'll have a string field for the name. We're going to have getters and setters and toString and all that kind of stuff here. Good. Okay, so there's my basic DTO, and kind of map it to customers. Okay, customer. Okay. Customers, good stuff. So for each row in the SQL query, I'm given a result set, and then for each result set, I'm going to build up an object by getting the ID and the name, and then mapping them to the object. Okay, so now that's a little bit long in the tooth there. It's a little bit verbose, so I can actually turn it into a lambda. And there we go. There's my my call to the database. It gives me a collection of customers, and then I can just visit each one of them by doing a for each or whatever. So for each customer, I want to print out the customer. And of course, this can be turned into a method reference like so. So there we go. There's our Java code. That's the entirety of the Java application. I have had to write, 2 lines to do anything interesting. And then there's a DTO. This is our domain model. So let's call that, what is that? 3 plus, well, that's 4 plus 3, 7, 8, 9, 10. So 10 lines of interesting code to get my application doing something with the database. Let's try it. Let's try that. Let's run it, see what we get. I might have gotten the table name wrong. Is it customer or customers? Okay, we'll figure it out in a second, one way or another. Looks like it was probably customers. It says invalid object name customer. That's a clue. All right, there we go. That worked. There's our data. And of course, that is the long way around, right? This is like if you wanted to do everything the hard way. For a lot of people, they're going to be using an ORM, an object relational mapper. So I could use something like JPA here. And JPA is it's a bit heavier, but if you want the things that it does, then you can use that with ease. So you just create a repository, and here I'm going to say it's a customer repository. It extends the JPA repository, whose types are of type customer, whose primary keys are of type integer. And with that done, I'm going to inject not the customer, not the database template, but the repository itself. And then for that, I can just do customer repository dot find all dot for each system dot out print line. Okay, so that's the updated code. The other thing I need to do is to map this this to a primary key. So there we go. Okay, let's run this and see what we get. Oh, and I also need to. Oh, it's gonna fail. I forgot to do entity. Now it should work. Take two. Okay, invalid object name customer. Oh, right, the table. I have to give it a table name. And it's customers, name equals customers, or customers, just to be sure. And voila. Okay.
Now, some mappers, if you had named the class customers, would it auto have mapped that by guessing?
Yeah, exactly. It would have done that, but I should have more. If it was greenfield, I could have just done the right thing and named the table customer, and that would have been fine. But whatever, it worked. So there you go. And you can see we've got the same records using this low level repository. And now I get a whole bunch of, I can do many to many relationships, one to many, bidirectional, all that kind of stuff without writing a single line of SQL code if I want to avoid it for the simple stuff.
Yeah, so this is awesome. So really easy. I mean, you would start to spring.io, boom, get all of your stuff up and running. And I think the other nice thing here is, especially SQL in itself. So for a lot of customers where you're running SQL on-prem and you're migrating it to SQL Azure, one of the things that I really like to highlight is just the fact that you can have automatic index tuning on SQL. This is something that you can do today in SQL on-prem, or you can do in SQL running on IaaS VMs. But our managed SQL does this as well. And so it will drop and create indexes for you. And so I know, especially like, if you're talking to your DBA team and you say, hey, look, your production databases, when you move into Azure, or like just if you are going to keep them on-prem, why don't you just flip this little bit on your production databases that will go and create and drop indexes, because SQL is smart and just let it do it. And so, especially DBAs, like, I remember like, running production databases for customers that were running manufacturing lines, and it's like, you don't touch the database. That's just one thing you never do. Well, especially a lot of people that are moving to SQL and are doing greenfield, you don't necessarily know how your databases are being used nowadays. And so, we did a case study internally of one group inside of Microsoft where they were running 348 servers with 830 databases. And so they had moved those all to SQL paths, Azure SQL Database. And one of the things that we did for them was we didn't tell them we were doing this. Probably not a great sysadmin thing to be doing, but we turned on automatic index creation, automatic index tuning across their 830 databases. And we didn't actually know which of those were prod or non-prod. We knew a good chunk of them, if probably half or a little bit less were prod, but we just did it. And so, after a couple of weeks, we started to see the results come in, and people started to freak out because they're like, hey, my data's gone because things are running a lot faster than they should. Like, did I lose things? And so we collected the data after about a month, and across those 830 databases, We created 2,200 indexes and we dropped 5,700 indexes, and we reverted 97 of those changes because let me be clear, SQL automatically reverts it. So if you just turn this on, it'll just say, look, I'm going to go change your indexes, or drop or create, or just manage them for you. So everything runs faster. And we found over those 830, after about a month, we had dropped 263 billion reads per day off those 830 databases. And so, A, there's maybe there was a bad query in there, or B, frankly, when people build stuff in SQL and it sits around for 2, 3, 5, 10 years, access patterns change, DBAs change,
right?
How that application is being used has changed, the schema changes.
Yeah.
And so I think this is just one of those things where, even in production, just the default, if you're using SQL Azure, go into your ARM templates, set an Azure policy, the default should be automatic index creation, automatic index tuning is just on. It's and the nice thing here is it'll go and create indexes. So it uses more storage on the server, but we don't charge you anymore because we keep you within your same SQL tier that you said that you saw earlier. But because your database will now get so much more performant, you can typically ratchet down the tier that you're paying for. And so, it's not great for our field that's getting paid for SQL Azure consumption. It's super good for customers. So you can go save yourself a bunch of money, have your database perform a lot better just by trusting the statistics and the AI and ML behind it.
Yeah, that's exactly that's a perfect example of why you want something like a hosted platform to run your database, right? Because it can do more. It has more insight, it has more visibility, and there's a whole team that's dedicated to finding wins like this and just applying it for you on your behalf, right? And you may not, and suppose this didn't exist, right? It's just nice to know that Microsoft's working on it and that it will exist eventually, right? It's one less thing for me to figure out, even if I ever had time to figure it out in the first place, right? That's awesome. That's so cool.
It's nice
Billions of reads.
And it frees DBAs to go do more meaningful work. Kind of like Spring. It frees devs to go work on meaningful work as opposed to everything else that they have to deal with.
Right, and we love that, and gets you to production faster, which hopefully that's
take your kids and your family, right?
Right, exactly. That is so cool.
All right, well, thanks, Josh. I think we've got a whole bunch more that we're going to be doing with some other Java people at Microsoft.
Yep.
Thanks a lot, and we'll see you again soon.
Thanks.